Alright, hopefully you feel pretty confident going into this little trig review quiz. It's not going to be a big deal, but just kind of make sure you're good. Let's kind of walk through these. So 60 degrees obviously is right there, and across from 60 in our reference triangle is square root of 3. 1 is across from 30, and 2 is the hypotenuse. Sine is opposite over hypotenuse, so we would have square root of 3 over 2. Again, that should have felt pretty comfortable, pretty easy. The same thing here. 135 is right here, gives us a 45-degree reference angle, and so we go 1 square root of 2, and then we went in the negative x direction, so that'll be a negative. Positive y direction, that'll be positive. Tangent is opposite over adjacent, so 1 over negative 1, which is negative 1. Okay. 300 puts us in quadrant 4. Gives us a 60-degree reference angle. So when we make this reference triangle, across from 60 would be square root of 3. 1 here, 2 there. We did go in the negative y direction, so that'll be negative. This will stay positive. Secant's reciprocal of cosine. So instead of adjacent over hypotenuse, this will be hypotenuse over adjacent. Hypotenuse over adjacent, 2 over 1 gives us 2. 3 pi over 2 is 270 degrees, so that puts us right there. Again, let's just go down one spot. That'd be at the point 0, negative 1. That's our cosine, that's our sine. We're looking for the sine, so negative 1. For this one, 5 pi over 6, we're going to be at right there with a reference angle of 30 degrees. So 1, 2, square root of 3. We did go in the negative x direction, positive y, so we're all right there. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse is negative square root of 3 over 2. That'd be our answer. 5 pi over 3 is 300 degrees. And so we go right there. 300 degrees gives us a reference angle of 60. So across from 60, square root of 3, 1, 2. Positive x, negative y. Cosecant is the reciprocal of sine, so instead of opposite over hypotenuse, this is going to be hypotenuse over opposite. Hypotenuse over opposite, 2 over negative square root of 3. The negative could be in front or right there, it doesn't matter. Okay. 5 pi, each pi is 180, so 1, 2, 3, 4, 5 puts us right there. That is negative 1, 0. Cosine, sine, and therefore we have a cosine of negative 1. And then this one here, 7 pi over 4. Each pi over 4 is 45 degrees, so 1, 2, 3, 4, 5, 6, 7 puts us right there. You can do it as a degree, 315. Either way, you're going to get 45 degrees as your reference angle, and that gives us a 1 square root of 2. We went the positive x, but the negative y. Sine is opposite over hypotenuse, so negative 1 over square root of 2. So again, hopefully that feels very comfortable. If not, you need to kind of go through our stuff again. It's the same thing each and every time. Don't overthink it. Just make sure you know your reference triangles when you're doing it. All right. Then in terms of solving these out, what we want to do is get the cosine by itself. So we would subtract 1, divide by 2. We'd get cosine theta equal to negative 1/2. So we'd start by saying, well, what quadrants is cosine negative? And that's quadrants 2 and quadrants 3. So then you build a reference triangle that's in that quadrant. Cosine is adjacent over hypotenuse. So my adjacent side is negative 1. My hypotenuse is 2. And then you kind of go back, well, which of my reference triangles would this be talking about then? In this case, it would be the 30, 60, 90. And that would give us a reference angle of 60. Okay, so that's good. Then the next step is to say, well, what would have been the big angle then that would have created this reference triangle? And in order to create that, we would need to go 120 degrees. And then the last thing is we'll just change that into radian form. So 60 is pi over 3. 120 is just double that. So we get 2 pi over 3. That'd be our first angle. Okay. Nice news is that when you find your reference angle for the first one, it's going to be your reference angle for everyone. So we don't have to reinvent this. We can use 60 here. And the full angle that would get us there would be 240. That's double what we had here. So double this gives us 4 pi over 3. So those are our two angles that satisfy this equation. Okay. For number 10, we're going to divide by 4. We get cosine squared theta plus 1 equals 1. Subtract, I get cosine squared theta equals 0. So I'm looking for when does cosine equal 0. Now, a couple ways to do this. I could use the cosine graph, which looks like this, and it hits 0 at pi over 2 and at 3 pi over 2 based on its graph. Or I set up the unit circle and I write down what each of these are, right? And we know that at here and here, cosine is 0, otherwise it's 1 or negative 1. So pi over 2 and 3 pi over 2 is our answer. And then for our last one, the 3 theta, again, that's something a little new, and if it kind of freaks you out, don't panic. What you want to do is just ignore it first and ask yourself, when does tangent equal negative 1? So tangent is negative in quadrant 2 and in quadrant 4. And we're looking for the opposite adjacent to equal 1. Well, that only occurs when the opposite and adjacent are the same thing. So this is going to be our 45, 90 right triangle. Okay, so quadrant 2, 45 would be 3 pi over 4. And then if we go to quadrant 4 and do that, we're looking at 7 pi over 4. Okay, so what we've done is we just forgot about the 3 theta. Don't even worry about that. When does tangent equal negative 1? When you take the tangent of 3 pi over 4 and 7 pi over 4. Now what we say is, well, then 3 theta could equal either of those, right? And then we divide by 3, and we get theta equals 3 pi over 12, or pi over 4, and 7 pi over 12. Okay? Now this is all good. If you could do this, that's excellent. We'd be real happy. There is technically one more thing we can do, because there are some other thetas between 0 and pi that would satisfy this. We're not saying 3 thetas between 0 and pi. We're talking about just theta itself. So what we're going to do is we're going to add 2 pi to each of these and create some more options here. So instead of adding 2 pi as written as 2 pi, I want to have it as a denominator of 4. So we're going to add 8 pi over 4. That's still 2 pi. And when I add it here, I create 11 pi over 4. Okay. And then I'm going to add 8 pi over 4 to this. What I'm doing is just turning this one more time around, still ending in the same spot. That would put me at the angle 15 pi over 4. Okay. Then if I divide those by 3, I end up getting 11 pi over 12 and 15 pi over 12. Now I want to stay between 0 and pi. So 11 twelfths is still less than 1, so that's still less than pi all. But 15 divided by 12, that's bigger than 1. So this will actually be bigger than pi. So here's my final answer. I want 3 pi over 12, 7 pi over 12, 11 pi over 12. Right? Hopefully that felt good. If you're just stuck on one little spot, that's not something to get freaked out about. Good luck tomorrow. You'll do great.